So we've looked at and covered the basic skills of calculating the limits of a sequence, determining if they exist or not, and calculating them using the limit formula. What I want you to do in this video is I'm going to set you a few questions here. I want you to pause them, have a ping at the questions and come back and then check your answers against the working that I'm going to present after this. So here you go. First one, determine which recurrence relations below have limits and calculate them if they exist. So there's 3 of them there. Do they have a limit? What is it? Second one, at the beginning of the war, 10,000 Spitfires were in the RAF. The Commander-in-Chief estimates 20% are lost each month in combat, but 800 new fighters are created. Calculate a recurrence relation for this. How many fighters are left after 1, 2 and 3 months? And what the long-term position of the RAF be if the war continues indefinitely? Last one, Princes Street Gardens cleared once a week for litter. 8% is collected. Each week visitors drop 100 kilos of litter. What will happen in the long-term situation if there was initially 500 kilos of litter? So, pause the video, have a go at these 3 questions, and then come back and check what you've done. So here you go. First things first, determine which recurrence relations below have a limit and find them if they exist. Now remember, our general formula for the recurrence relations, un plus 1 equals a un plus b. And this here is the part that determines whether or not we have the limit. So for this, a has to be somewhere between 1 and -1. Another way of writing this is the magnitude of a has to be less than 1. 2 different ways of representing it both mean the same thing. So you can essentially look at it and read off if a limit exists. The first one, the a is 0.6, so we know a limit exists for that one. The second one, the a is 1.62. The limit does not exist for that. 1.62 is bigger than 1. It's not going to exist. It's just going to expand and get bigger and bigger and bigger till it goes off to infinity. And the last one, number 3, a is 0.88, so we know a limit's going to exist there. So now we have to calculate the limit of these 2 sequences. So the first one, we know the limit is equal to b over 1 minus a. So we know that's the limit formula. We have to then be able to calculate it. So b is your last term, a is your term here. So in this case, we know that our limit is going to be 20 over 1 take away 0.6. So that's going to be 20 over, well, 1 take away 0.6 is 0.4. It's sometimes better to write that as a fraction. So it's that divided by 2/5. So 20 divided by 2/5, that's the equivalent of 20 times 5 over 2, which gives me 50. So my limit for that one is going to be 50. So the third one, remember we don't worry about calculating this one here, number 2, because we know it doesn't have a limit. So the third one, again, stick with the same formula, the limit equals b over 1 minus a. The only difference is, as b and our a change values. B in this one is given by that term, a is given by the 0.88, so it's going to be 5 over 1 take away 0.88. Now 1 minus 0.88 is 0.12, and that is the equivalent of 3 over 25. So it's the same as saying 5 divided by 3/25. Flip it, turn it into a times, we get 5 times 25 over 3, so we know that's going to be 125 over 3. You can leave it like that, or write it as 41 2/3. Both mean the exact same thing, both give you the same limit. So calculating the limit, determine if it exists, that's how we have a crack at it. We then look at some scenarios. So the beginning of the war, there's your Spitfire count. This is what happens. First we have to create a recurrence relation representing this, and then 3 months worth of calculations. So remember a recurrence relation, un plus 1 equals AUN plus B. The way to think about it, that's what percentage we're left at the end of each month from what we had, and that's what we correct it with or we change. So estimates 20% of the planes are lost in combat each month. Well, 20% lost means that A is what's left, so it's the 80% left. And we write it as a decimal, so it's 0.8. And the B is whatever extra we get, but we know we get 800 new ones every single month. So we know B is going to be 800. So I can set up my recurrence relation un plus 1 equals 0.8 un plus 800. So now I want months 1, 2 and 3, so I essentially want to calculate U1, U2 and U3. So I need to figure out my starting value. Well, that's here. Beginning of the war, 10,000 Spitfires. So for U1, I know I want 0.8 times 10,000, add on the extra 800 that's going to occur. Calculating this, what you end up getting is 8,800 planes. We can then do the second year, so 0.8 times our previous year, so that 8,800, add on the other 800 we're going to get. Stick that on your calculator and do it, you get 7,200 planes. Third year, we take the 7,200 from the previous year and times it by the 0.8 this time. Then we add on the 800. Doing that, what we find is we've got 6,560 planes left. So it's decreasing by an amount. It's not a consistent amount each year, though it changes per year how much it goes down by. Now, we want to know the long-term effects and the long-term position. So we know it's going to have a limit. Look here, at A is 0.8. It's going to head towards a limit. So at this point we can say, fine. We know the limit equals B over 1 minus A. We just need to figure out what B is, what A is, and plug it all together. Well, we can read them off from the formula. We know A is this bit here, so it's 0.8. And B is the correction bit at the end, so in this case it's 800. So in this case, I know my limit is going to be 800 divided by 1 take away 0.8. So it's 800 divided by 0.2. Now remember, 0.2 is a fifth, so it's the same as 800 divided by a fifth. Flip it and that becomes 800 times 5. So our ultimate aim and our ultimate situation is we're going to have 4,000 fighters left. So we're never going to fall, as long as this behaviour continues, we're never going to fall by having below 4,000 fighter planes left. Last one, Princes Street Garden cleared out once a week, 8%, 100 kilograms new added each week. There's our starter one. So the first thing we need to do is come up with a recurrence relation for this. So we need to know un plus 1 equals A times un plus whatever our B is. And remember, A tells you what happens each year, and our B is the correction part. So in this case, we know that A, it's 80% is collected, so it's what's left. We know if 80% is collected, we've got 20% left. So A, we know, is going to be 0.2. B, 100 kilograms are dropped each week, so B is going to be an extra 100, so it's going to be add 100. So we know in this case our un plus 1 equals 0.2 un plus 100. And we could say, fine, we also know our first term, u0, is 500. Now we could plug all these values in together and work it through gradually, but we're able to look here and say, well, that's less than 1, the size of that is less than 1, we know a limit exists. So what we're able to do is look at the long-term effects in one step using our limit formula, b over 1 minus a. Looking at the formula, there's our a, we know that, and there's our b, it's the 100. So we know it's going to be 100 divided by 1, take away the 0.2. 1 minus 0.2 is 0.8, so it's going to be 100 divided by 0.8, which is the equivalent of 4/5. Flip the fraction on the bottom, and it becomes 100 times 5 over 4. 100 times 5 quarters gives you 125 kilograms of litter. So what we know is we're never going to go below 125 kilograms of litter. It's always going to be sitting there, unless we do something to change the behaviour, get people to drop less, or pick up more per week. So calculating our limits with these functions, these are the key things we have to remember. We have to remember looking at, does a limit exist? If it does, what parts do we need? How do we calculate it?